is to what I mean by product of. First of all, what does product mean? You multiply. So GCF of 36 and 90 is, let's multiply. What are we multiplying? Smallest powers of what? Common factors, right? So now, do you think it's easy to see the common factors now that we have, right, now that we did prime factorization for each of these numbers? Yeah, you can see all the factors, right? You see how nice when you do a factor tree, you can see all the common factors. What are the common factors for both of these numbers? Yes?
Okay, there's
2 and
3 squared. Wait, there's 3 times 3?
Right, so 2 and 3 are the common factors, right? So we're going to multiply, but yes, you're right. We need to choose the what? Smaller powers. What about 2? Look at 2. 2, you see how 2 is common in both, right? 2 is there, 3 is 5 common factor? No, 5 isn't in here, right? Does that make sense? So now it says choose the smallest power. We got 2 to the second, 2 to the first. Guess which one we're going to use? 2 to the? Which is smaller? 2 to the, is 2, which one is smaller? 2 or 1? 1. So you choose 2 to the first power. What about 3? We have 3 to the second, 3 to the second. There, that one you don't have to worry about. Which one we're going to choose then? 3 to the second, because they're both the same, right? Does that make sense? Guess what? This is your then GCF. What is 2 times 3 times 3, guys? 2 times 9, which is 18. This is the GCF. In other words, 18 is the what?
Greatest common factor.
Meaning 18 is the biggest number that goes into 36 and 90. Is there any other number that is bigger than 18 that will go into 36 and 90? No. If you follow these steps correctly, you are guaranteed to have the greatest common factor. Question?
For the, okay, it says the common factor that is the smallest power.
Yeah.
How is 3 to the second the smallest?
Thank you. I was just going to ask that question. Did you hear what Talin said? Why do we choose a smaller power? What do you think we should choose? Choose the bigger one, right? Because aren't we, after all, looking for biggest number that goes into both? And we're looking for greatest common factor. Why do we choose the, after finding the common factor 2 and 3, why do we choose the smallest? Why not choose the bigger exponent? You know what I mean? Thank you, because I was going to ask that question. Exactly. So why? Elizabeth, do you see why? Yeah?
There was only 1, 2.
That's right. Say it a little bit louder.
For one of them, there was only 1, 2. For the other, there was 2.
Yeah, exactly. If I would have chosen 2 to the second power, Talene, that's fine. It goes into 36, right? The 4 will go into, but does that 4 go into 90? No. We want to make sure that that number we get as a GCF must go into both of these numbers. So if you were to choose a higher exponent, it will go into one of them, but it will not go into the other. Does that make sense? That's why we choose the smallest. Does that make sense? Yeah.
But how is 3 to the second the smallest for 9?
No. So look at just well, smallest of 2 and 2. They're both same, so we just choose 2. Does 3 to the second? Will 3 to the second go into 90? Yes. Does 3 to the second go into 36? Yeah. So if they're the same number, you have nothing to worry about. But if you have different, same base but different exponent, you choose a smaller one.
So you could have done 2 to the second.
I could have done what?
Like, you know how you did 3 to the second?
Yes.
For 36, you could have done 2 to the second.
No, I could not have chosen 2 to the second. Then, if I chose 2 to the second, it will not go into 90. See, this only has 1, 2. Does that make sense? Do you guys understand what I'm talking about? Yes.
Basically, like if you have 3 to the 4th and the new one, you have 3 to the second, you can only use 3 to the second.
That's right. You know, so very good. So because I knew people were going to ask this, try this one. I've done all the factor tree for you. I did the step 1 for you because I don't want to do all that stuff. Go ahead and find the GCF. Okay. Everybody, go ahead and try. Look at the step 1 and 2. I've done step 1 for you, right? Because I was nice. I did it for you. So do step 2. Tell me the GCF. Okay. So GCF of this whole number is what? These two number. I don't even know what they are. Is I don't know what by. Go ahead, everybody try.
Is that m to the 12th or 11?
Oh, it says 2 to the third, 3 to the second, 5 to the third, 7 to the second. The other one, 2 to the third, 3 to the 8th, 5, 11 to the 12th, 13 to the 14th. This looks like M? This is not M. Really? Okay, it's 11. Sorry, it's 11. Is that better? Okay, sorry. Okay, now, so what's our step? Look at step 2. It says to do what? So we did step 1 for you. I did it for you because I didn't want to. Step 2 says to do what? It says product of. So how do you find GCF? Now you need the product. What does product mean? You multiply. What are we multiplying? Common factors. So what are the common factors for this? No, I don't even know what they are. Yeah, 2 is common factor. What else? So times 3 times 5. Is 7 a common factor? No. What about 11? What about 13? No. So we're looking for greatest common factor. So you can't include factors that are not common. Now, we're not done, are we? We have to choose which exponent. Now, 2 to the third, 2 to the third. Compare both of these. Well, they're the same. So guess what? It's going to be 2 to the third, right? What about 3? 3 to the second or 3 to the 8th? What about 5 to the third or 5 to the... This is what? 5 to the? First. So we just 5. Guess what? We have found the GCF. Now, if you can, you should... Yeah, that's it. How many people got this? Raise your hand. Very good. That's it. That's your GCF. This, whatever this number... What is this? 8 times what? 9 times 5. 360. Is that 360? Are you sure? Okay. Okay, very good question. Guys, Judy asked a really good question. Do we leave it as exponential form? After you do that, if you can multiply it out, you should multiply it out. If it's just numbers. But if it's really, really big, you don't have to. But, if it's something that you can multiply it out, you should. Yeah? I'm sorry? Oh, well, okay, that's a very good question. Who could answer? The question is, how do I get 5 to the first? Who could answer that? Raise your hand. Why? Okay, what do you think it should be? You think it should be 5 to the third? No, look at what's the 5? This 5 is 5 to the third power, isn't it? Right? That's the common factor, right? 5 and 5, right? This is 5 to the third. This is 5 to the what power? First. Which one's smaller, 3 or 1? 1. That's why we choose 5 to the first. You see what I mean? Because we want to make sure that 5 has to go into both of them, right? That's why we choose a smaller exponent of the 2. Does that make sense? All right. Really quickly, then try this example. This is really important because this is actually, I got this from your homework, okay? So it says list all pairs of factors of each integers, okay? I don't want to show you all the answers. Okay, list all pairs of factors. Now, does this say positive factors? No. So do you think we could have negative factors? Yes. So take a look at these. Let's do this quickly. It's not that hard. What about 20? So they say list all pairs. So let's list them as pairs. Is that okay? So what times what gives you 20? What's the easiest one? Yeah. 1 times 20. Okay, that's it. Oops. 1 times 20. That's an easy one. That's one pair. Is that the only pair where we get? Can you give me another one? 2 times 10. Is that the only one? What's the next one? 4 times 5. Is that the only one? Do we have all pairs of 20? Not quite. What have I forgotten? Yes? Yeah, all the negatives. So do you think I get negative 1 times 20 is one of them? So on your homework, if they say just factors, yeah, you have to give both positive and negative factors. You know what I mean? You can't just give me half of it. Huh? Yeah, that's it. So how many pairs of factors of 20 do we have? Yeah. 6. There are 6 pairs.
The same thing doesn't go with the negative.
I'm sorry?
The same thing doesn't go with the negative.
Yeah, so how do you do? Everybody try B then. If you got A, everybody go ahead and try B. So how many pairs do you think you're going to get for negative 20? Any guesses? Yeah, Sarah? Do you think you get 12 of them? Oh, 6 pairs. Yeah, I see what you mean by 12. Yeah, that's the exact. So can you give me one of them, Sarah?
2 times negative.
Let's start with the easiest one. 1 times negative 20. If I could have 1 times negative 20, you think I could have negative 1 times 20? Yeah, see, one of them has to be positive. How come both of them are not negatives? Yeah. Then it would be positive. The second one, do you see how it's going to be negative 2 times 10 or what? 2 times negative 10, or we could have negative 4 times 5 or 4 times negative 5. We also get 6 pairs. Does that make sense? Any question? Are we good?